On to number 7. These are vocab sort of problems for number 7. Says, give an example of a trinomial. Your answers are going to vary. Okay? What's key to know is that tri means 3 pieces, and a piece is dictated because it has a addition or subtraction sign in between it. Okay? So we're separating these different pieces with addition and subtraction. They need to be unique. So for example, a basic trinomial will be something like x squared plus 2x plus 5. These numbers can all be different. These variables can all be different. Okay? But what would not count is if you gave me something like 5x plus 3x plus 2. You know, that's debatable because you can combine these to create a monomial. So be very careful with the trinomial. Play it safe. Give me a squared term, a single x term, a constant. Give me 3 distinct things that I cannot combine. And they should all be separated by addition or subtraction signs. Answers will vary. Okay? B says list the coefficients of this polynomial. This polynomial has 4 pieces. So we've got to list all the coefficients. A coefficient is a number in front of a variable, even when it's hidden. What I mean by that is, look here. This first variable doesn't have a coefficient, but it does. It's a 1. So that's our first coefficient. -7 is clearly a coefficient. It's in front of variables. And then look here. This is also a -1. And then our final coefficient is a 5. So you just list all the coefficients that are in front of variables, all the numbers that are in front of variables. Those are coefficients. C says name the constant term. A constant term is just a plain number all by its lonesome. Well, the only one of those we have here is a +4. D says how many terms are in the polynomial expression. A term is dictated whenever we have an addition or subtraction sign separating them. There's an addition sign, there's a subtraction sign, so we have 1, 2, 3 terms. It doesn't matter that this first term is really long and complicated and the second one isn't. It doesn't matter, there's still a term, so we have 3 terms. Also note that this is a y to the 5th, z to the 4th, which looks like it can combine here, but this one has an x, so these aren't like terms. Similarly, this is the x squared that's missing, but we can't combine it there either because they're not like terms. These are all 3 unique items, and they're separated by addition and subtraction, making them 3 unique terms. Number 8 says classify each as rational or irrational. Remember that irrational numbers are those crazy numbers. When you think of the word irrational, you think someone being crazy or not being sensible or something like that. That's kind of what these irrational numbers are. They don't make a lot of sense. Rational numbers make sense, okay? We've used rational numbers all your life, all the time. Irrational numbers are the ones that are a little bit crazy. If you're not sure, you can check it in the calculator, but I know that 49 is a perfect square, therefore this is actually going to equal -7. That's a pretty normal number to me. -7 is a normal number. It is rational. Now, the actual way to tell if something is rational is if you can write it as a fraction. It's really not good to think of just normal and abnormal, but it gets the point across when you think of the word irrational. The fact is -7 can be written as a ratio, namely it would be -7/1. If you can write it as a fraction, it is indeed rational. It's a ratio. Square root of 38 though, that's not a perfect square. Because I know 36 is a perfect square, and then the next closest one is 49. What is the square root of 38? I don't know. Let's do a little quick test just to make sure we're not wrong. Square root of 38, nope, that's not a pretty answer. And that number does not stop here at 3. Does not stop there. That's just where our calculator runs out of digits. It's going to go on forever and ever and ever and never repeat. This number is kind of crazy. This number is irrational. Okay? C and D are things that you can test on your own. They're simple facts that we had in our notes. Okay? C says the product of an irrational number and a non-zero rational number. We want to know what that is. Okay? Well, you can test it yourself. You can use some of the other ones if you knew these were irrational and rational, or you can think of some of the basic ones that you understand. An example of an irrational number, a common example, is square root of 2. And a non-zero product, meaning multiplication, and a non-zero rational number, well, let's just pick, 5. Non-zero meaning don't pick 0, that will mess this up. Also, you can just memorize this as part of your notes, okay? It was on the review, something like it is probably gonna be on the test. You can just memorize this from your notes. Well, when I multiply those together, I'm gonna get 5 times the square root of 2. And I sure look, and that looks like an irrational number to me. It's crazy. It's not got any set pattern. Therefore, I have concluded this is irrational. Now, once you get up into higher level mathematics, that's not okay. You can't do that, okay? It's a false proof. I didn't actually prove anything. I just tested it. It was a given statement, and I tested it. I picked an example, okay? Also, like I said, you can just know from the notes that this is an irrational answer. Similarly with D, the sum of 2 rational numbers. Well, rational numbers are ratios. They're fractions. They're things we understand. And when we add 2 of them together, we're going to get another rational number. Okay? A sum, meaning add, of 2 rational numbers is also rational. You can memorize it from the notes. You could just make up an example yourself and figure it out. Let's just pick some fractions. 1/2 plus, because it's adding, 3. I don't know. That's just 2 rational numbers that popped in my head, and I'm just testing them. But when I add 1/2 plus 3, I get 3.5. That's a pretty normal number. It's not one of those crazy numbers that goes on forever and ever. And in fact, I can write it as a fraction, and our calculator can do that for us. If you press math, enter, enter, it will turn your last answer into a fraction, 7/2. So I knew this was indeed a rational number.